Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about how to use transaction pooling with prepared statements to make Postgres up to 30% faster. We'll start with this blog post by Lev from the Postgres ML team. And this has a very bold claim, which is they're going to make Postgres 30% faster in production. Now, I would say let's add a few more details to that 30% number, but I think there are some interesting aspects here. Lev and team maintain a new connection pooler called PgCat, which is written in Rust, and the idea is it's more scalable than existing poolers such as pgbouncer and pgpool. Let's dive into some of the technical specifics before we jump into the benchmarks later in this post. Let's go into the GitHub PR that added that feature to PgCat. This is adding support for prepared statements both in session and transaction mode. If you're familiar with poolers, most of the time when your goal is to make efficient use of connections on the database side to reduce your idle connection count, you're going to use transaction mode. Transaction mode means that when your client opens a connection to the pooler, that same connection does not map one-to-one to a connection from the pool to the server side. Instead, the connection pooler is going to multiplex the connections to the server in order to save on the idle connections on the Postgres server. What's unique here is that we're able to use prepared statements in a place where usually we haven't been able to use them. Prepared statements have a lot of benefits in terms of saving planning time for your queries. Usually when you send the exact same query to Postgres, Postgres will run a new execution plan. That can be quite expensive. But when prepared statements are in use, Postgres is able to cache the query plan in many cases and is able to reuse it for future queries. That way you can save on CPU time and also get sometimes more predictable query performance. This work by Lev and team here is based on a patch for pgbouncer. Before we dive into this, let's just briefly take their description of what this is doing, because I think this applies consistently to the approach taken in PgCat as well as the patch to pgbouncer. To understand how this works, when the prepared statements is already prepared, nothing happens. If it is not yet prepared, we prepare it on the server by sending a bind and execute. The notable difference to normal behavior here is that this actually will rename prepared statements to unique names and keep a mapping between the client-side name and the server-side name. The problem here is that, for example, when you have an application like Rails, Rails will actually assign prepared statement names like A1, A2, A3, and it does that for each line. Usually they have independent connections and prepared statements are per connection, but if they're not independent, if they're actually multiplexed thanks to a connection pooler, then you'll get conflicts between two different connections on the client side. What PgCat does here, and is necessary to make this work, is that it actually remaps from the client-side name, like the A something, to a server-side name that is random and unique. Now, again, this promises a big performance improvement. Let's take a look at the pgbouncer patch. This pgbouncer patch was contributed by Martin Dashorst about a year ago. And this, I think, is a very appealing patch, and it's not the first version of that patch either. But what they've done is that they have implemented this in production. They had a migration from Oracle to Postgres, and they saw a big problem with the high CPU usage, and so they wanted to do something to improve that situation. A lot of graphs are in this post here, but I think that even the top graph shows you a very nice story. You can see here on the left side, this is a usual weekday traffic for them. Then on the weekend, they have a low period. And then you can see on the Monday here, they didn't have it rolled out. And then they rolled out the pgbouncer with this prepared statements in transaction pooling mode patch. And then you can see a noticeable difference between that CPU utilization and CPU utilization on the left of this graph. Whether that was actual 30% in this case, I'm not sure, but it, I think, clearly shows that there was a real-life improvement on a production workload. The other thing to notice about this patch is that this has been open for about a year. So the question is pgbouncer going to add support for this, or should we be changing to something like PgCat? The good news is, more recently, I saw this post by Jelte Fennema on the hackers mailing list, where he left a side note here saying, we're actively working on implementing name-prepared statement support for pgbouncer in transaction pooling mode. Jelte is part of the pgbouncer team that he recently joined. If you're not familiar with the pgbouncer development history, pgbouncer has existed for quite a long time, but for many years, up until I think about 2 years ago, there wasn't much activity. Peter Eisentraut took over and did a bunch of maintenance releases to pgbouncer, but there still hasn't been a lot of feature development. And so what's really exciting here is that the Jelte and team at Citus are actually starting to work more on pgbouncer itself. And it looks like we can expect a lot more active development around pgbouncer than previously, which I think is really exciting, and we should see a lot more good new functionality coming to pgbouncer. Now, there is a new patch that they've worked on for about a month. This is still work in progress, but I have hopes that pgbouncer will also get support for prepared statements in transaction pooling mode. Coming back to the initial blog post below for PgCat, they actually run a more simple benchmark here using pgbench. And you can see that they essentially compared when there's a high number of clients, what's the number that they can get. Even in the case of pgbench, there's a clear improvement. And really this comes down to being able to use prepared statements, which because of these savings on planning time, will get you a big performance improvement, which may be up to 30%. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.